Yep, that's right. If you see a blue guy there.
How are you? Anyone needs to leave really early? Constraints? I'm telling like before 7 or before 6.
I have a thing at 7.
Hmm?
I have a call
Okay,
at 7.
yeah. Okay.
I mean,
Yeah, I want to.
okay.
When we will approach the end of the semester, sometimes there could be maybe twice per semester we may run into the deadline where we need to sit longer. So probably you all are curious about homework number 1. Yeah. We'll go over it. And there is a initiative. So in about 2 weeks from now, we'll have another session of presentations. So right now, by trying a couple of homeworks by pen and paper, you realize that even if you are strong, intellectually bright and intelligent, sometimes it takes your precious effort and time for solving problems. And it would be good if you can replace human effort by computer. Therefore, we're adding this little computational component, and since there is nothing complicated, but we will need to have some hands-on. And the best way to get through this practical aspects will be with basic skills that we will make us sign up later in the class and split these skills over everyone. So so I'm going to cover some of these skills. We already tried doing it informally a week ago, and I do have intentions to demonstrate, to invite you to solve homework 1, problem 3 together by computer, as a just to see how it looks like, and then we can go into analytical derivations and come to a true solution. Maybe I will keep a little secret so that there still will be opportunity to improve grades. So not solving everything, but going far enough that we feel comfortable. So okay, yep. So if you see this list, there are about 4 chapters, 4 skills that we will have. Basic use, matrices, visualization, and programming. Right? Can you please, I'm learning your faces and names, but can you please lift hands if you were not here last week? Okay, yeah, thank you. So please try to open Matlab software on your, just log in and open. So if you just type here Matlab at the name of the code, you'll see this symbol, and if you click on it, it should open. We already had some practice, some fun last time, and there are almost all operations that we may design as part of this course are done by computer, and it is in a little bit quicker way than a human would do. So will it be visible with this font for everyone? So it uses command line, so you type something, same as you chat to each other or send SMS. You type something and it replies something back. So of course you can do simple arithmetic like 1 plus 2 and it will answer, like as a calculator. And I did send you some PDF, but if you browse and just explore it by pushing different buttons, you'll see some manuals and helps will pop up, and probably you'll learn it much quicker than I can explain. So there are same functionality as for calculator. In addition, you can take square root of -1, right? So this code is trained to understand complex numbers, right? Or if you have exponential of pi, if you recognize the rotation of phase in the power of exponential. So you change angle, and it shows how the angle in the power of imaginary exponential is represented by a combination of real and imaginary things. So done with number one, whoever, like complex numbers in Matlab, right? Functions. So you can set up arrays or just set of numbers so that it continuously covers values in a given range. So it is a numerical way to define the argument of a function. And then if you do it this way, you can draw some functions. Well, it depends on, I don't have much creativity, therefore I'm plotting something simple. But You can just practice different functions and plot them by just typing plot. Right? Well, I'm covering it quickly. When you practice it and prepare a presentation in 2 weeks, you can dig deeper and find some other functionality. What is the derivative of a cubic function? So quadratic function, right? So if we take derivative of this cubic function with 1 whisker up, 1 whisker down, we should get 2 whiskers up. Let's try to type. So if you type diff, it will be simplest implementation of derivative in finite differences. It just subtracts the neighboring elements of an array. And you saw it. We get kind of derivative from cubic to quadratic parabola. And same you can convert from like derivative of cosine to get minus sine, right? And other things. So we are quickly covered basic use before functions, and now let's look on the maybe a couple of minutes later. Also, see, right now it's like a calculator with very short messages, but you can open so-called script and combine several commands one after another, and then run them again and again, right? It's a basic idea of programming. So let's look on the bless you. Let's look on the homework that did started pleasing you guys. My understanding. Did anyone completed this problem 3 or not yet? No, I don't want you to.
Here?
No. So, what do we have here? What do we encode in these equations?
That's a question.
What these mathematical equations do encode? What do they represent? What is y1 and what is y2?
Are they wave functions?
Yes, well, we are not telling that they are wave functions for electrons, it's just waves of some nature. But are they standing or traveling waves?
Travel.
Yes. Which direction are they traveling?
They're going to meet.
Yeah. So I'm going to play lazy. I just typed quick code. We can type it together, but I will already send it to you by email. And if you run it, so whatever we practiced by this basic skills, we can write down the things towards the homework. So we should define some argument range, and then we can redefine time step in a cycle, like for and then we can just write down these two waves. So later on we will add them together, but maybe let's just plot this. Well, I shouldn't keep much intrigue and secret because you can run it already, right? So please leave hands if you didn't run it yet. I did send an email to everyone in the class. Please leave hands if you have already tried to run it. Okay, Please leave hands if it runs successfully. Okay, so I invite everyone to run it as well, and I will run it here. So this dash sequence is first and second traveling wave. So you see it keeps same height, and one moves to the left, another moves to the right. And once upon a time they meet and interfere constructively, and some other time they interfere destructively. So sometimes it adds together, sometimes it adds with negative sign. So, do you see any observations about the summation of these two functions? Like the dashes travel, right? Does the solid line travel anywhere? So it stands, right? And one can like finger a point on a figure that doesn't change its value. It will be 0 all the time. So the question in this problem to find all values of x at which there will be 0 value of function at any time. Okay? As a first step, let's do it just with means of this Matlab script, and then we will do it, or you will do it analytically for a grade. But at least we get general idea what we are looking at. So your computers are expected to work a little quicker because this one is saving our session and it substantially slows down. Your should be like 10 times quicker. So after it gets through so many steps, it should make a little break, pause. And if after this, after it stops, you click once again, it will run once more, but you know the movie is reproducing the picture again and again with deleting previous one. And if you keep this line each time it redraws, it's kind of traces where this function was. So we have this point. And if I do not want to play any intellectual concentration, just quickly find the answer, there is a way similar as in Excel and Origin, this data cursor. You just point right space that you want, and it is expected to give you the values of minus 2.87. Then I go to the next one, point minus 2.37. And to some extent, if you just give this set of numbers, I do not have rights to say that it will be a wrong answer. It's correct answer, we found it. Right? It will be a little more glorious and useful if we give the answer not in form of sequence of numbers, but as a formula. So you see the offset between all of these nodal points is the same, right? And so it is proportional to linearly growing natural number, integer. So we need just to find how far it is shifted and what is the coefficient to multiply by integer, right? Okay.
How do you get it to look like that?
Oh, but probably I was too excited that you would walk around and see that you dealing with this.
No, I just tried to run another code after it.
Oh, no, keep it. So if something doesn't work, share experience with each other. It will be much bigger and better way compared to one person working on it. Just chat and ask if someone is not seeing the images.
I copied that in my phone.
This is not very, this is possible.
Yeah.
I think I definitely just went there.
That's a thinking.
I don't know. I literally just ran another thing because I saw it deep. I had minus looking at
I just mentioned stuff. As long as Mr. Williams.
So
Because you should have all these over here. It's stuff like this. You don't have so you don't have an offset out in here. Yeah.
Sheesh. I don't know.
You should get the answer It just forces the computer to recycle. So Michael, if you go, so Michael, if you zoom in, that's what I had.
Even Zoomer?
even farther. So I'll see if I can do it again.
I can't go on. Very close. I'm sure you're max value.
Sorry, Michael, I zoomed in a little bit. So it got me the cross. It looks like someone's like crooked. It's just the same picture. That's what happens when you zoom in. It's above your wrist. Above your wrist. Raise.
That's me. Something is.
Yeah. I can't.
That's down.
Maybe not stop. Are we supposed to just write down the x values and get this? Is it not that close?
You can do it as a quick one.
Hey. Let's run it on.
No.
No, I'm saying on here. So what happened? Because the way I got mine to pop up, well, I literally just ran out of the script by looking at the x point on this graph. I just want to see what would happen if I divided it by 5. So I hit 1 and then it actually got to the matrices process.
You're so smart.
No, I did not mean to do that.
It's very complicated.
Well, I mean, so when I read this, I only got this one.
Yes,
so then-
So this one is
What is CD's going to count?
change the look.
There's that 40 bucks.
It is- it is-
See, as you can tell.
Because it was just the same day. Very, very.
Oh.
So a lot of people were just like,
Well, it's
oh,
not
I have nothing to do with it. And then it's probably. Yeah, it should be okay. Because then we have more people. We have
Oh,
a lot
just
more
wants to do
people.
it enter again?
Well, he doesn't batch enter because he didn't even use any
Ah.
or at full price.
So you go to.
I would, I should.
No, well, I had that, I'm like, did it, but then I went back.
So, yeah,
And I went
Not
back.
sure.
I didn't know that.
but
I saw like 208, and that, but then it just like went back to this. I know, I did that.
or just get order McDonald's on a day after. And use the code 20 and we get 50% off.
That works for us.
Yeah.
You do too.
It's really nice in the summer. Or like
Let's start
in April,
over.
because there was the Vikings, the Twins,
Context.
and the Wild,
What?
and the Lakes also.
Even in Fargo.
Even Fargo. And if somebody gets if they lost, somebody in the community leagues have a grand slam, it's like, I don't know, new boss slam, that's 40%.
Pretty sure I dropped that one.
They don't do that anymore?
Yeah,
Okay, so it was 2021.
well, that's up to teams.
Yeah, but.
Mao did one last night.
Yeah. But you can always get 25% off, use the code 25 off. Except I haven't paid full price for pizza. Pretty quick.
Wow. 25 off.
Usually you can get a better deal now, but if falls fails, you really want to be the That's just up off the so I don't know anything forgotten.
Oh, and I like spicy. Which one I get spicy pie pizza every Thursday for $5. Get 2 pieces of pizza, the drink for $5.
Oh, yeah, I was gonna say, that was a good lunch. Yeah.
Yeah, we just go every Thursday, cause every day. Yeah.
So, your stuff should be.
Yeah.
Instead of
Three-quarter and booster. Oh, well.
Once next year.
I mean, think about it, nice bonus, I can most of
We get free items for 2 years, so.
Okay.
right now I have. So like,
Honestly, that might be not.
let me go from here, because I wrote down all these ones.
Oh, you are so efficient. Workaholic. It's good.
Okay.
So you got this, right?
Yeah.
Well, keep exploring Matlab, and I'll probably focus a little bit on analytical solution of this problem. And when we will either solve it or when I feel tired, we'll get back to more of the Matlab skills, because it gets much less stressful. So, what if we would have no phase factors? So right now we have something here, but what if we have no phase factors? How would we solve this equation? What would happen? So first we would need to convert summation of two functions into product form, and then find where it takes 0. I'm going to spend a little more than necessary time. You got these charts with equations. My intellectual strength doesn't allow me to memorize them. I fail. So anytime I need these equations, I just rederive them. And maybe you carry this chart with you, or you will memorize it, or let me show that they are doable to rederive approximately at the same, maybe a little longer than just we'll find them online. So if we do have, this is A, this is B, this is A, this is B, just sum and subtraction of 3 trigonometric function of the same argument. I will just practice Euler equation a couple of times. So on one side, I would write exponential of a sum. On another side, I would write exponential as a product, right? And both of these expressions can be expanded into Euler formula. Sine A plus B plus I sine A plus B. And here it will be cosine A plus I sine A from the first exponential times cosine B plus I sine B. And then if I have steam and energy, I can open brackets and write down cosine A times cosine B, combining everything with real and imaginary part together. E, so I times I will be minus, and it will be real part. Minus sine A sine B. And for imaginary part, it will be cosine A sine B plus sine A cosine B. So this left and right part must be equal. So real parts must be equal and imaginary parts must be equal. So if we need to process the first function, it will be expanding sine of A plus B, sine of this stuff. So it will be cosine times sine plus sine times cosine, right? Stop me, lift hands if it sounds like nonsense or not interesting. So the dashes underlined stuff will help us to process function y1. Now I do need to repeat the same thing for the subtraction of arguments inside the brackets of trigonometric function. So I will just briefly reproduce the same expression, just practicing calligraphy and replacing b to minus b. So, e to the power I a minus b equals cosine a minus b plus I sine a minus b on the left part, and on the right part it will be e to the power IA times e to the power minus IB. Which will be cosine A plus I sine A times cosine B minus I sine B. So cosine of negative argument is again the cosine, and sine of the negative argument is minus sine, right? You do not object. If you just plot the function, you see this property. Yes, of course, I'm writing in most hidden place that you don't see any notes. And then I'm writing with unrecognizable non-calligraphic so that you don't understand anything. So if I have energy, I can open the brackets. And it will be 4 terms which we can group those that do not have imaginary unit in front and those that do have imaginary unit in front. So it will be cosine A, cosine B. And now we multiply I times minus I. I times minus I, what will be the sign? Positive. Well, it was negative once when we had I times I. Now we add one minus sign and therefore it will be plus. Plus sine A sine B. And for the imaginary part, I'm opening the brackets. Cosine A with minus cosine A times sine B. So I do this and this. And now plus sine A cosine B. So there are differences in these two sets of equations. So this minus became plus here, and this plus became minus in here. So in order to process our function y2, we will need imaginary part. This and this. I know what I'm doing is not the shortest and most efficient way.
So why did you bring English formula into this?
Because I do not remember formulas for conversion sine of summation into product of sines and cosines.
Okay.
I'm just bringing it up.
Okay, you're deriving.
Rederiving formulas,
Okay.
right? Huh. Let's check if maybe I do not need to stand. Maybe I can just sit. I don't know if you would like it or not, but it's probably will be a little easier for me. I'm just trying to see that I can adjust. Okay, good. So I'm just redrawing sine A plus B will be equal to cosine A sine B plus sine A cosine B, right? From this equation, and sine A minus B will be minus cosine A sine B plus sine A cosine B. So for our purposes of adding together traveling waves, we do need to put plus sign between these two things, right? So we do not care about these equations themselves, we need only the summation. And if we add together these two equations, this term with opposite sign will cancel, right? You agree? So we have sine A plus B plus sine A minus B equals sine 2 times sine A cosine B. So this is our function y1, this is our function y2, our A equals 2 pi x, our B equals pi t, right? So our y1 plus y2 equals 2 sine of 2 pi x times cosine pi t, right? And now I can practice drawing this function of x and t. So if I have the x-axis, let me draw at time t equals 0, when cosine will be cosine of 0 equals 1. So it will be changing from -2 to 2. It will come through 0, and when x equals 1, it will make the whole period of sine. When x equals 2, make another period. When -1, it will make another full period. If I wait for time going over different time steps, we will see that the function will come through these zeros and again and again, but at the points of maximal amplitude it will come with different phase, and it will be maxima with different sign, but by absolute value it will be maxima. So what we need to find only the points when spatial part is always equal 0. So it will be 0, 1/2, 1, 3/2, 2, right? So we did it graphically. And now we can just solve it, write down sine 2 pi x equals 0. We know that argument of sine must be equal to pi n. 2 pi x equal to pi times n, where n is integer. 0 plus minus 1 plus minus 2 plus minus 3. And this is the only equation for us to solve. So we cancel pi, right? And divide both parts by 2. So x equals n divided by 2, where n equals 0 plus minus 1 plus minus 2 plus minus 3. So it will mean that x equals 0 plus minus 1/2 plus minus 1 plus minus 3/2 and so forth. So this is the answer in absence of the phase factors here, right? Let me go around and ask for questions. Otherwise, I can sit here and entertain myself and without feedback. I don't want you to show everything, otherwise no, I have right to do that. But it is clear.
Yeah, it's priced.
I'm following you to this point so far. Yeah.
Homework 1, problem 3 by Matlab by equations. Almost done by equations. So I do have several ideas how I could do this, how I could deal with the phase. And I was generating answer key, but a couple of years ago, I don't remember what is an answer key. I am on the same page with you, completely fresh. So, one idea that may or may not work. I'm just sharing. So, the problem is that once we do have plus pi over 2, and another we have plus pi, or otherwise, right? So there is a phase shift. One probably can solve it in 3 ways. By using phase relations, by shifting the x-axis, and just by going completely into imaginary space. And going to imaginary space will guaranteed will be longer, but if you do not do small mistakes, it will bring to the answer with guarantee. So phase shift. So if we do have sine x, right? And if we shift system of coordinates by pi, so x prime will be equals x plus pi, which means x equals x prime minus pi. Can we say that by phase shift by half period, we will get again trigonometric sine function of the same period, but with opposite amplitude, right? Okay, so whenever we have plus pi, we can just remove this pi completely and put minus up front, and then practice as we did before. If you do sine of the x plus pi over 2, so we start quarter period later, not at the 0 but at the maximum. Can you say that sine of x plus pi over 2 is cosine? Okay, so you just replace function, and then select which of these equations is applicable and try to practice it as we did before. One way. Another way I was suggesting to one of you, but I'm not sure if I did it before myself. If we do have one function shifted by phase pi over 2, another by pi, we can identify midpoint between these phase shifts and consider that we are in between. Find some symmetric system of coordinates. So we can migrate this phase shift under the x spatial part. So if you put the pi out of brackets here, then this pi over 2 and pi will convert in 1/4 and 1/2. And then it will be reasonable to just shift system of coordinates halfway back between these two phase shifts. So if we redefine x shifted by 3/8 and in x prime, then in new system of coordinates, it will be like the time part will be with plus and minus as before, and for space part it will be shifted to opposite sides. So it will be symmetric shift by plus and minus 1/8. And then rolling over these equations, it may bring us to symmetric answer, but then one may need to return back to original system of coordinates upon getting the answer. I probably try the first method first because it is promising to be the quickest. And the last one will be rolling through Euler equation once again in the opposite direction. So if we subtract these two equations, so cosines will cancel, so it will be 2i sine a. So sine of any function, no matter what are the phases, can be represented as e to the power of this argument minus same argument with negative sign divided by 2i. And if one converts the wave into sinusoidal part into exponential, then all writings will be longer, lengthy, but any dealing with phase factors will be straightforward. You just use the fact that exponential of summation is a product of exponentials, and you just pull any factor to the front. This is more general, but it will take longer amount of paper to derive stuff. Okay? I don't know. We kind of done with mini program. You can try sit and write it, solve this problem for yourself. and if you try different things, I can try to help. And I'll put on the screen Matlab again, and maybe those of you who are not in the mood to derive something probably will continue entertaining with some basic functions of Matlab.
Yes, so you look at the
So what I saw was for time here. So this is the time stuff. So now, and the travel stuff is zero and
I'll probably accumulate feedback and
Do you mind if I just put a big cross through this and start writing it out?
whatever makes you comfortable.
so lost. So.
can I bring your attention for related to problem number 2? Maybe you have completed it, but I collected some feedback and you may fall into trap. I didn't make this trap. Yeah, some of you may set it up for yourself. So let me share what I've, well, my freshman undergraduate years were in physics. Let me share quickly what I've got in my freshman physics year 27 years ago. So, second derivative of position is force divided by mass. And if we are just above the ground, it is free fall acceleration, right? No one objects. If you want to see how the, so, and it is second derivative. If you go back to the first derivative, it will be velocity. So if you know the acceleration and you want to get the velocity, we need to integrate acceleration over time, right? From the initial to final point. Since our acceleration is constant, it will be, and you follow the rules of integration, it will be initial value of this y dot of the velocity minus acceleration times time interval, right? So velocity changes linearly, deviates from initial value. And if we throw something up, it first it decelerates, it goes slower and slower, slower, and then it starts accelerating down, linearly. Because integral of a constant is a linear function, right? Now, the trap. If you go from the velocity to coordinate, we need to integrate the velocity, right? But our velocity is time dependent. It is already linear in time. And if we carefully perform this integral, we are getting initial position, initial velocity times times, and then what is the integral of linear function? Quadratic. So it is acceleration times t squared over 2. Okay? If you may be well aware, I hope it is nothing novel in here. These considerations were, well, now a little of information which is, if you ever need to teach at high school. So these considerations were really important at the time of Galileo for development of a really important practical application of this medieval times. It is the background of cannons and artillery. Because based on these equations, you develop one projection for y, another for x, and then you count time, then you compute the trajectory, and you find the distance where your projectile will land as a function of the angle where you put your cannon. So if you decide to quit with science and go into military, you know the secret how to predict where a projectile will land.
For number 2, can you just use kinematics equations instead of using derivations?
Well, it's not an equation. You do not need to derive it.
Okay. I was like, yeah.
Another question. So if it is the opposite,
I mean, after the phase shift with the pi, would you just put a subtraction sign in front of that whole function then? Or do you not even have to consider it, even since it doesn't actually affect the nodes? Because now here's my reasoning for putting a subtraction sign. If sine this equals, if the original y2 equals sine x blah 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 plus pi, now wouldn't negative y2 equal sine 2 pi x minus pi t?
So you are changing sign only in front of one function.
Mm-hmm.
So you're changing addition to subtraction.
Mm-hmm.
Probably it is safer to keep the sign.
Okay, I didn't. That's what I thought, but
Yeah.
I just don't want that one affected.
Listen.
Number 3. Should there be a T in the final answer? Or should it just be?
No.
No? Okay.
So when you did it with Matlab, there was no T.
Oh, yeah. Yeah.
So it's just a stationary point, which is the same for any time.
Yeah. Okay. Okay. I'll try and figure out how to get rid of it.
Bless you.
Did I follow this right? So this top part is if there was no phase change, which
Mhm.
gets me here. But then if I apply a phase change of pi over 2 pi, basically x plus 1/4 and x plus 1/2, does this get me down to 2 pi x plus 3 pi over 4?
I wouldn't. I'm not a congenius to fall in a second, but it seems correct approach, and I want to build by shape and by logic. It looks correct.
Okay.
I will not be grading on the flight, but I like the way, and it looks like a real answer.
Okay. Right. Here.
No, I get that. I just realized that's why I need next time. I figured that out. I got you. Is that plus or minus depending on the equation? Okay. Yeah, I understand. I just in case. Huh? What? For what? X prime doesn't do derivative, so it just means the
Oh.
Yes, right.
It took me a second to figure that out.
So if you're not solving, or if you're tired of solving and want just some entertainment, well, best entertainment would be some nice figures and images, and some of you already found that if you type demo, enter, it gives you hundreds of options of looking through nice pictures. But we do have a program, so maybe what I'm going to offer right now is not as visually appealing, but it is a practical part where MATLAB can replace some of the mathematical effort. So in, I don't know yet who will select this part, but probably this is too complicated, it can be split one more, but inverse matrix. Please give me a sign if you never took linear algebra. 1, 2, 3. So the rest took some linear algebra. 4.
I'm in linear algebra, right?
Okay. Okay. So can you solve this equation? What is the answer? I have solved this equation 5 minutes ago, and I'm sure I was just challenging myself, and this is simple enough to solve.
Is it alright if we solve the equation by taking it out of matrix form first?
Huh?
Can we solve the equation by taking it out of matrix form first?
Oh yes, absolutely, absolutely. So it is like x plus 2y equals 1, 3x plus 4y equals 2. Can you do it in your head or really quickly?
There's no solution.
I found there is a solution. Huh? What is equal?
Y equals 1/2.
And x equals?
0.
Yeah. Cool. Thank you. Well, right now, with such strong mathematicians in the audience, probably we do not need Matlab. But what if it will be like not 2 elements, but 100 elements or 1,000? We may need a helper like computerized helper. So this is the point where we stopped last week. So a matrix can be like called with a capital, unknown set of variables as a vector can be called like vector x, and this is unknown vector c. So a times x equals c, right? So it is a rewriting of this matrix equation, of system of linear equation in vector and matrix form. So if we want to solve this equation symbolically, so a and c are known, and x is unknown, right? So there is a standard way to solve equation like this. So assume that we divide left and right part by matrix A, capital. And dividing by matrix meaning multiplying by matrix minus 1. A minus 1 times A times x equals A minus first times C. Logical. Now we assume that matrix divided by itself will be 1. And then this means that x vector equals A minus 1 times C. So the matrix A minus 1 is called inverse matrix, right? And it is defined as 1 over determinant with elements of algebraic complements. You may close eyes and ears. I will go through these things with Matlab much quicker and much more pleasant. Just if you're super curious about notations and stuff. What is determinant of this matrix?
Over the determinant or
Just determinant. Oh, lift your hands if you never. Huh?
10.
Lift hands if you never heard the word determinant for matrices. Okay, everyone did. You take, if it is 2 by 2, you product of diagonal minus product of off diagonal, right?
Negative.
Let's try once again. 1 times 4 minus 3 times 2 will be minus 2. 4 minus 6. So if it will be plus, it will be 10. Minus 2. So algebraic complements is like transpose and take everything except the element. So algebraic complement for this element will be 4. Algebraic complement for this will be 1. Algebraic complement for this one will be 2 because we do transpose, and here is minus, and here minus 3. Yeah, I think so. And if we divide it by minus 2, it will be minus 2 plus 1 plus 1.5 and then minus 0.5. So, if linear algebra is correct, then multiplying this matrix by our free term, by 1 and 2, will give us the answer to the equation. So let's let's check if this hocus pocus works. So if the theory works, the answer should be 0 and 1/2. Let's check it. So row by column rule. Minus 2 times 1 plus 1 times 2. 1.5 times 1 minus 2 times 0.5. So minus 2 plus 2 will be 0. 1.5 minus 1 will be 0.5, half. So either both Bill and linear algebra are wrong, or both are correct. So you saw it by hand manipulation. Right? Now let's see if we can do it in Matlab first for this simple example, and later we probably will be able to apply it to something more complicated. So in the Matlab, I'm typing A equals 1 space 2, next line 3 space 4. What? 3, 4. Close bracket. Good. So we have the matrix A. If you type determinant A, we are expecting to get minus 2. Yes, determinant is minus 2. If you type inverse of A, we are expected to get this minus 2 plus 1 plus 1.5 minus point. Look here and there, right? Inverse matrix. Now, another numerical experiment that I skipped here. The main property of inverse matrix, if you multiply inverse matrix onto original matrix, we should get identity matrix, right? Matrix that has ones on the main diagonal and zeros everywhere. So let's call this one A1, 1. And now we multiply A1, multiply by A. Focus, focus. And you see it is identity matrix, right? So we kind of trust Matlab because it reproduces what we did by hand on the board. And based on this test, later on we can apply it for the same class of problems of much bigger dimensions. Right? Now let's try finally this thing. So inverted matrix by free term. So if you call our C vector equals 1 and 2 vector column, and now we multiply inverse matrix times C. Yes. You see, x equals 0, y equals 0.5. So from now on, whoever will select the question on matrices can tell about, well, probably everything. Transpose is trivial, right? You know what transpose is. So if you have A and you do A prime, the off-diagonal terms should swap. Right? 3 and 2 are swapped. And if you have a vector and you do prime, it converts it from column to row. Transpose. Also, if it is something imaginary, it will also flip the sign of imaginary stuff. Good. Let me circulate along the rows and then check if you are ahead. No, that's not single start.
But how much of that left goes?
Yep.
Is that the net, is the prime just the transpose?
Transpose and it can come with some truth.
Oh.
AI stands for artificial intelligence.
Oh, it's just me.
No, that's fine, that's fine. What did you do?
I got bored and I did that one to be funny. And then it gave me that. I don't know. But I do. So I do. C.
Okay.
I don't do this stuff.
So, let me share something. If you, instead of untitled,
Yeah.
you save this, give some.
Let's try it, or 3x3s.
Yeah, save it. And later on, if you want to
Yeah.
want to save it to send it yourself, you can browse through.
Okay. Makes sense.
Because otherwise, You don't want to retype your codes every time you come into the class.
Yeah.
Do you have steam to more things, or it will be kind of sufficient for today? Okay. Okay, then meeting is dismissed. I'll just sit here in case you guys have questions, but let's not overuse your precious resources.
So, all that, my leg's too close. Okay.
You go take some full foods.
How many are great? Wow, I know where I guess I rank the priority scale then.
Mine sweepers of all.
That's fair. I'll probably just download that one.
I'm pretty sure it's just automatically on, like, if you go wait, but this, yeah,
Doesn't
you might,
matter.
Yeah, it's math.
You can probably find it in the app store.
for like $300, is that just Apple pricing for you?
No.
No, mine's the first for me.
No, I see some of
And then
Yeah,
iPhone X now costs $2,000.
No, it's only 1100.
Only. I'm going left.
See you later.
Good night.